Hey everyone, geophysicist Stefan Burns here. Breaking news, we have just had a massive earthquake burst off the east coast of the Kamchatka Peninsula. This is just north of Japan. This is Russia. And this is crazy. There was a magnitude 7.4 earthquake and also 3 magnitude 6.6 earthquakes. There's a little bit of flux right now with the magnitude values. The 7.4 seems to be stable, but originally the foreshock, which is now 6.6, was categorized as a 6.7. So just minor discrepancies, but there was also a magnitude 6 earthquake. There's been magnitude 5 earthquakes. A massive amount of energy has been released right here along this subduction zone, and it goes it's just about 2,500 kilometers to the west of the magnitude 7.3 earthquake that struck Alaska just a few days ago. This is the 16th of July, and today we're talking about the 20th. And so we seem to be having this wave of seismic energy that's now hitting the Earth. We've been talking about this on the channel nonstop now for a while because we've been seeing the space weather indicating that we are going to see an increase in global seismicity. And well, here we are. We had the 6.7 in the bond to sea originally down here. This was on the 14th, and then this 7.3 followed up afterwards. That was quite significant. And now we have this most recent earthquake burst here just off the coast of Russia, and it's just also 2,500 kilometers away from Japan. So specifically, this is a 2,500 kilometer difference, and we can actually measure this right here. So we'll go from Alaska, put my head in between, to Kamchatka, and we see that's 2,500 kilometers, okay? And then we'll do our next segment here, going to Tokyo, all right? Tokyo is this metropolitan area there. Look at that, 5,000. So it's exactly the same distance away. Now, I'm not saying that Japan is next, but we do have another coronal hole soon to enter into the geoeffective position. We've been hit by 3 high-speed streams just in the past week. Those are starting to ebb off now, but this next coronal hole high-speed stream is about to impact in just a few days. These are specifically linked to increases in global seismicity, specifically high-magnitude earthquakes. And now we see this 7.3, this 7.4 with the magnitude 6s. This cumulative magnitude is a 7.6. And this area that we've been watching on the channel, Japan, for a whole bunch of reasons, which most of you are well aware of at this point, been watching the channel, that is the same distance as this distance right there. So the synchronicities, you could say, keep piling up. This is not a doomsday proclamation for Japan. We really hope that nothing happens there 100%. There is an earthquake swarm that has been occurring off the south coast of Japan. 2,000 plus earthquakes been going on roughly since June 20th, so nearly a month now. And this earthquake swarm is the largest that they've had in a long time. Years and years and years. We've had magnitude 6s, or sorry, we've had magnitude 5s as the highest magnitude in the swarm. I think a 5.6 is the highest, maybe a 5.8. We haven't had any magnitude 6s in this yet, but a bunch of magnitude 5s, and of course all the lower magnitudes, 4s, 3s, 2s, just basically constantly popping off. And swarms often, not always, but often are actually foreshocks to a large event. That is something that has occurred and will continue to occur throughout Earth's geologic history. So this very well could be some sort of foreshock earthquake swarm sequence before something larger, because the way earthquake energy scales is that, yes, you are dissipating seismic energy with this swarm, but let's say a magnitude 8 is to rupture there. And these are all just middle magnitude 5s at the highest extent. The cumulative magnitude for this is probably about a 6.2 or 6.3, maybe 6.4 at this point. And the general rule of thumb is that a foreshock will be 1 magnitude less than a main shock. And so just because you've had a magnitude, let's even round up to a 6.5, okay? Just because we've had a magnitude 6.5 there, and it's less than that, does not mean that you can't have something bigger. A 7.5, all of a sudden, that's 32 times more energy released than a 6.5. So this earthquake swarm does not rule out the possibility of there being a high magnitude earthquake. And if we look at the globe overall, okay, we had this 7.3, now this 7.6 cumulative. It's actually like a 7.59, but the 7.4 and all the sixes. And now we have the swarm there. We had the magnitude 6.7 in the Banda Sea. These are the three biggest earthquakes that we've had just in the past week, really bumping global seismicity up. But we haven't had a magnitude 8 since August of 2021. I've repeated that over and over, but it bears repeating because that's the largest, once you get to a magnitude 8, you're talking about the big earthquakes. And we haven't had one in 4 years, and we typically get one about once every year. There's of course variability with this, but usually there's one magnitude 8 somewhere on the globe every single year. We're like 4 years overdue. So there is definitely a lot of seismic energy that has been bottled up that's starting to release. And yesterday in the live stream, I talked about this significant earth shift that's unfolding right now, and how we have a big energy spike coming up on the 24th to 25th due to the convergence of the new moon as well as the space weather. And this is a big energy spike. This is an even bigger energy spike. There could perhaps be even something bigger than that coming very soon. It is possible. If we, for example, had looked at this 6.7, been like, okay, that's the biggest earthquake we're going to have for a while, we would have been wrong, because then we had the 7.3. If we had done the same thing for the 7.3, because that's a fairly significant earthquake, like that's the biggest we're going to have for a while, we would have been wrong again, because now we have this. So just because we have that does not rule out the fact that something bigger could be on the way. We don't know, but there are a lot of factors, as I explained in depth in yesterday's live stream. You can go to my channel, click the live tab. If you want to watch that for all the nuanced explanations across a whole range of domains, science and more, then you can watch that video. But in this video, we're going to just focus more specifically on exactly what's happening. I'm going to give you a report on this. We're seeing some really crazy ionospheric anomalies right now, at least according to our GlowTech model. So we're going to talk about that because that's really weird. This is some really weird stuff. And then we're going to hold a question and answer at the end. So if you have a question, you can ask that at the question and answer part by typing @Stefan Burns, or better yet, you'll get preferential treatment if you donate a super thanks and add your question to that. And then I can pull those up at any time. So that makes it so I will actually see your question and answer it. Please stay on topic when we get to the Q&A. I'll talk about that more when we get there. We're going to come back to Google Earth, and hello and welcome everyone to the live stream. If you're new here, I'm your host, Stefan Burns, geophysicist, space weatherman, cosmic weatherman, just a curious human being trying to understand what's happening on this planet. I feel like I'm very in resonance with the Earth, the sun, and the cosmos, and so I consider it one of my duties to report on these things. I love learning. I know a lot of people love learning, and so I consider myself just like a teacher for the public. Let's look at our GlowTech model, and let me explain what this is. Because on this channel, I don't just tell you things, I educate you so you can learn and look at this stuff yourself. You don't have to rely on me for the video, because this happened about 8 hours ago. This earthquake sequence basically happened the moment I went to sleep in California. So if I had been up, I would have reported on it then. So I'm sorry I'm a little late on this, but you know, sleep waits for nobody. Here we're looking at the ionosphere, specifically the total electron content. And the ionosphere is the uppermost part of Earth's atmosphere that has a little bit of plasma to it, the fourth state of matter. And so you have solids, and then you have liquids like water here, where the molecular bonds start to break apart. Solids have like these crystalline bonds, right? They're all fused together. Liquids, they can start to move past each other, the molecules, but they're not energized enough to actually break apart. And then with gas, all of a sudden now these molecules can individuate and they bounce around and fly around. And that's the atmosphere that we breathe. and it's more energetic. As you go from solid to liquid to gas, things become more energized. There's just more kinetic energy in these molecules. A plasma has enough energy to actually break apart the molecule and strip the electrons off. So now you have a positive group, like let's say for hydrogen, which is a proton and an electron. You have just the proton, and then you have just the electron. Now they've separated, and now they can move differently under the influence of a magnetic field and also electric fields. So in the uppermost part of the atmosphere, about 1% is plasma. That changes depending on space weather factors, sunlight, and things of this nature. You see that it's less, there's lower total electron content on the nighttime side, and there's greater total electron content on the daytime side because the sun is always pumping out light radiation like ultraviolet light and more. And this ionizes these molecules. And so you have this ionization effect that occurs when the Earth rotates into view of the sun. And so there's always a lower charged part of the ionosphere and then a higher charged part. And there's variations in things that occur there. But you see these these propagating waves of the ionosphere near the equator. That's where the sunlight hits it the most directly, cuts through the least amount of atmosphere, and so you get stronger ionization. But look at what the heck is happening here. I've never seen this before. This is really crazy. We're going to watch this a few times. But you'll notice our scale bar here going from lowest TEC to highest TEC, okay? But look at these bursts all of a sudden of high total electron content that have popped up here. And you'll notice, watch our time. These earthquakes that occurred in Russia started right, let's just average it to about 7 a.m. universal time. Watch how this starts just before and then right after they really start happening. So that's really bizarre. I don't know what the heck this is about. It seems to be connected to earthquakes. It could just be an error in the model, but this is fed from a whole bunch of different data sources. So I'm not thinking that's the case. My intuition's telling me that's not really the deal here, that there's something bizarre happening. And what we see with the research is that, well, earthquakes are fascinating, first and foremost. We often observe electromagnetic signals before earthquakes, like pre-earthquake signals. These can occur minutes, hours, days, even weeks or months in advance of high magnitude earthquakes. Magnetic field fluctuations can be observable if you really know how to crunch the data, and we have experts on it, like 6 months or a year before a high magnitude earthquake. This is changes the Earth's overall magnetic field in that zone. Very subtle signals, but they do exist. People have done the research and teased out the signal from the noise. And then we also see with earthquakes ionospheric disturbances, usually during or after, sometimes before, and these are known as TIDs, or traveling ionospheric disturbances. And the larger the earthquake, the stronger these traveling ionospheric disturbances. We also will usually see after an earthquake, like in the immediate aftermath, you'll see a depletion in the total electron content. So what we're seeing here is the opposite. Normally after a high magnitude earthquake, the ionosphere will be depleted temporarily of electrons as that seismic wave propagates out. You get these atmospheric gravity waves that also propagate out, and that changes a whole bunch of things through more mechanical, physical means. But there's also these electromagnetic effects that occur as well. But instead of seeing decreases in the TEC and seeing, let's say, a greater blue splotch pop up here, this is Kamchatka right there, right? That's the Kamchatka Peninsula. Instead of seeing that, we're seeing that after that earthquake again, and actually before, but really after earthquake, again, 7 a.m. universal, that's when we start seeing these weird TEC, or total electron content anomalies. And not near Kamchatka, but actually more with Eurasia. So I don't know what the heck is happening. It's indicative, you notice it's on the daylight side, right? So it's indicative of something happening with our sun. We have had some minor solar flare activity. We could be seeing that reflected in the data, but that burst was weird. If we go back, what the heck was that? Yeah, so I need to go back a little further, okay? And let's actually maybe pause it right there. So we see that weirdo. I don't know what the heck that is, right? That's right near Madagascar. There's, of course, with these sort of models, you can't take them literally as gospel because there's different data inputs, and we're looking at a model. But this one is pretty good with its inputs and with its outputs as a result. And so I don't know what we're seeing here, but this is coming right after that magnitude 7.4 in Russia, along with the 3 magnitude 6s, the magnitude 6, and there were magnitude 5. So cumulative magnitude 7.6 earthquake. This is the strongest earthquake sequence that we have had since the magnitude 7.7 that struck Burma, Myanmar, Thailand, that whole zone. That was March 28th, 2025. We go down, we can see our TEC difference from the 30-day median. This is another good model to check out. And you'll notice that this one is also weird, and we see these splotches popping up. Look at that. It's actually even more apparent on the difference model, the anomaly model, we could call it. This is really bizarre. Look at that. And they're hitting, a lot of them are hitting Asia here. And right in the zone that we're kind of tracking. We're tracking the Ring of Fire on this channel right now because it seems that we have earthquake activity that is maybe due to hit there soon. We don't know. It's just a possibility. There's a whole bunch of ideas floating around for that. But if we go here back to Google Earth, let's just kind of get a broader perspective really quick, okay? So we have, this is what I was talking about less than a week ago, and I'll turn myself off, so just watch my cursor, okay? Here's that 6.7 with the Banda Sea. Here's the 7.3 with Alaska. This is before we had this earthquake with Kamchatka, okay? But we see that this Banda Sea earthquake is right here next to these fault zones that lead to Japan. And of course, with Alaska, we have this subduction arc there that leads to Japan. So the thumbnail that I created showed these seismic waves converging towards Japan. Now, whether or not that's going to be the case, again, like we do know, for example, that seismic waves will travel preferentially down the faults, okay? So you do get seismic energy, it'll preferentially travel down the fault, and you can also get this seismic energy to cause other faults to rupture. So I was pointing towards Japan with that one, and now most recently we did get this seismic energy to effectively perhaps cause these faults here to reach that critical stress faster and therefore rupture. Because the timing on this is crazy, right? Coincidence? I don't think so. You can make up your own mind. I don't believe in coincidence personally. I think everything has a reason, but that's up for you to decide. But we have this happen on the 16th, right? 7.3, big earthquake, biggest that we had since May 2nd with the 7.4 in the Drake's Passage, which is down here. If I zoom the Earth around and get it straightened out for you. The 7.4 was like right in this zone, Drake Passage, right? That was the biggest earthquake that we had since May 2nd, the 7.3 in Alaska. And then it looks like, you know, the energy basically just moved. And all of a sudden we get this 7.4 there. And that is the same distance, literally the exact same distance. If you were to take that distance between the two and put it right to Tokyo, boom, that's right where we are, 2,500 kilometers away. And we have this earthquake swarm that's already going here. There's been other earthquake activity across Japan as well, some in this zone. We've been having volcanoes explode in Japan. Specifically, there's a volcano down here in the south. I think it's this bad boy right here has been erupting, but it may not be that one. It could be this one. Either, I think it's actually this guy. I would have to look up on Volcano Discovery to get the name. But we've been having volcanoes explode in Japan. There's just a lot of energy in this region, and we have space weather that's coming in to add some more. So let's check that out. We can go to our Solar Dynamics Observatory. This is our data feed of the sun, and we have different angstrom views that we can look at. We're going to look at a 211 angstrom view, because this is one of the most important things. We have our view of coronal holes. So here we see this very large coronal hole on the sun taking the shape of like a hammer or a 7, a few different things you can stick your imagination to. But this is important because it's transequatorial, which means that it cuts through the solar equator. And that's important because all the planets are basically along the ecliptic plane, right? They're on this flat plane around the sun. And that the ecliptic plane specifically is the plane created from the sun to the Earth. Let's say I'm the Earth, right? So the plane in between us, okay? So when you have a coronal hole cut through that plane, its high-speed solar wind will definitely sweep by the planet. Whereas if it's up here, or like this one, where it's further down, it may only loosely interact with the Earth because it's going to flow more to the south for like this guy, or more towards the north. You really need that coronal hole to cut through the solar equator to confirm that it's going to hit the Earth. This one has a nice fat chunk cutting right through the equator. It also has a part right above, right below. We're going to get hit by that high-speed stream. And that's going to happen in just a few days because we notice that it's right now Earth center, and the geoeffective position is more about here. These high-speed streams also have open magnetic fields, so the magnetic field streams out rather than looping back in close to the surface. Eventually, of course, loops back in and connects in some way. But in general, it has this magnetic field that will connect strongly to Earth's magnetic field and create this direct flow of very high velocity particles from the sun to the Earth. And that is also characterized by low density solar wind. And there's a pretty strong connection. We've seen it time and time again on the channel where you get A, high speed solar wind, B, you get low density solar wind below 1 particle per cubic centimeter, and C, you get the magnetic field configuration to connect to Earth, which means it has a negative BZ component. You get those three things all in one go, and you have like perfect earthquake space weather, you could say. And some people are still denying that this is a thing, but if you just pay attention, it's like blindingly obvious. For example, we've been talking about the fact that we were in a global earthquake watch because of the coronal hole that came before this, gave us 3 high-speed stream impacts back to back to back. This is number 4. And these coronal holes have been on the sun now really since like October. This one down there has had 11 rotations. Normally they die out after like, a few. They can last for a while, but since October, it's going to be nearly a year. We're coming up on like the 1-year anniversary for this one that's now rotating to the far side. This guy's been there for a while too. They transmutate, they change, they open up, they close. This is a part of the solar corona, the outermost atmosphere of the sun, which is deficient in plasma. It has a lower temperature because that magnetic field is causing the ions to constantly flow out. So it shows up dark on this 211 angstrom view, but this is not a hole directly through the sun. It's just our imagery of the solar corona highlighting that change in density and temperature. But it does show that magnetic field configuration. And it's geoeffective in this position because that's how the solar wind spirals out. And so at this point here, it's actually spiraling like that. Whereas here, and if Earth is right in the center, right? Whereas in this position right there, it's spiraling like this and will hit the Earth. So that's why we're a couple days away from that. But if you look, just do the research yourself if you want. I've done this on the channel, but you can do it yourself. Look through all the highest magnitude earthquakes since we've had observations of the sun like this, which goes back to Skylab 1973. There may be some sources that go back further in terms of being able to see coronal holes on the sun, but I definitely know that our imagery that we got from Skylab 1973 shows these coronal holes nicely. You can look through those solar synoptic maps. Okay, I'm giving you the keys to the castle. You can look through the solar synoptic maps, get your list of dates for all the earthquakes magnitude 8 or greater, and you will find a coronal hole, either center or geoeffective, in that zone every single time. And the higher magnitude ones, they're usually bigger. Like almost every high magnitude earthquake, like 8.5, 9, they have big coronal holes right in that zone. This is a moderate one, but it is transequatorial and it looks like it's getting slightly bigger. So this is like significant that we have this coming up. Let's go to our real-time solar wind so I can show you these 3 other high-speed stream impacts that we've had, because this is, I think, one of the factors that's led to this. It's certainly not the only factor as it relates to global seismicity. There are a lot of factors. It's what is the critical stress of a fault? Is it near that threshold where it's like about to rupture? Is it not? What's the other global earthquake activity, loading energy onto faults? What's the moon doing? The moon has its tidal effect due to new moons and full moons, those stronger tides. That affects the rhythms of global seismicity. There's a whole bunch of things, okay? This is multifactorial. I've never said that's not the case. But if you take those other factors into consideration and you don't exclude, for example, the space weather as well, then these rhythms and trends start to become a little bit more emergent, and perhaps you can forecast them, which is what we've been doing on the channel. We have not been forecasting the location or the magnitude exactly when. It's just more been about when do we have, let's say, a burst of global seismic activity coming up, and just very broad brushstrokes for the forecasting, and that seems to have been accurate. So I'm constantly working to improve my forecasting and to not put out false alerts, right? You also don't want to just put out a whole bunch. Let's say you put out 100 alerts and one of them is right, and then you toot your horn. Well, the 99 false alerts maybe freaked a bunch of people out and they ruined your statistics. So we're being very careful with our forecasts here on the channel, always looking to improve them. But see, we see these three high-speed streams right there, 1, 2, 3, and look at what our solar wind density has done. This is the key. I think this is really one of the most important components as it relates to the solar wind, space weather, and the connection to Earth, and like maybe pulling these earthquakes out of the crust, because I think there's a plasma component to this. And when you have very low plasma density for the solar wind, which is what's, the energy field completely surrounding our planet, that seems to pull these, it seems to trigger these earthquakes, and that perhaps, I'm just saying perhaps, I'm speculating here. I think we do have evidence for this, so it's not like a complete zero evidence speculation. But perhaps that causes plasma to rise up through the crust, and when it passes over a fault, or a fault generates that plasma due to mechanical stress and pressure, it then causes it to go out, because we see earthquake lights often before, like right before, during, and immediately after high magnitude earthquakes that rupture on land. Because on land you have the Earth, and then you have the atmosphere, so the plasma will just go straight up. Whereas for the ocean, any sort of plasma emission from a fault at depth will be absorbed into the ocean, so we may not see it. But if you have an earthquake at night on land that's like a magnitude 7 plus, you'll probably see earthquake lights if we get that CCTV footage or someone happens to film it. We have a lot of footage of that. We know it exists. So we know there's a plasma mechanism here. And there's a massive increase in the electrical conductivity often of the atmosphere right in that troposphere zone where we live, often right before an earthquake, allowing this electric circuit to close, and therefore that flow of energy to occur. Because you have the global electric circuit overall. So when you have these high-speed streams, the velocity, I'm not sure, is the most important component. It's just generally you get low density with high velocity. And look here, our values are all under like 1. Like 0.1. That's the lowest that this will go. But we're in an extremely low density solar wind right now, and we have this next high-speed streams impact coming up. Let's go to our 3-day view. Check this out. Look at this. We've totally bottomed out here. This is very anomalous. This is not normal. We do not see this all the time. It's not like we've never seen this before. And we'll go back to 2011 with that magnitude 9.1 in Japan. That also had an extremely low density solar wind stream at that moment in time because of a coronal hole. But we're just now, we're not out of that low density yet. I mean, we went up here to like 0.6. That's still, anything under 1 is anomalously low. So our velocity now is low at 400 kilometers per second. Our solar wind strength is normal at 5 nanotesla. This is the magnetic field, but our density is still staying very, very, very low, at least as it relates to where we are in orbit around the sun. There's probably other parts of the solar system where the density is higher, but where we are right now on Earth, it's like a vacuum, pulling this energy out of the Earth, triggering these high magnitude earthquakes. Until this turns around, this earthquake watch, this global earthquake watch, I would say is continuing. And as the earthquakes build, like 6.7, 7.3, cumulative 7.6, we're only probably going to get bigger and bigger earthquakes. At least that's a possibility. It's a very real possibility. So this is very low. Let's go to our all-time data and let's look at March 11th, 2011 for that 9.1 Japan, which is the biggest earthquake that we've had since in the 21st century. The 9.0 Sumatra 2004 was big, but 9.1 of course is bigger. And yeah, so if you're new to the channel, hello and welcome. I'm your host, Stefan Burns, geophysicist, space weatherman, cosmic weatherman, and more. We cover all these things on the channel, the intersection and connection between these things like geologic events, earthquakes, volcanic eruptions, geophysical energies like the Schumann resonances, solar activity, space weather, cosmic forces, even metaphysics and beyond. I bring all that together, present videos almost daily. If you like the sound of that, then please subscribe, smash that like button, help this channel grow, get this information out to more people. It may help them because it's good to be prepared for these things, especially live in an earthquake-prone region. It's always good to just be prepared, to have emergency supplies on hand, 72 hours of water, a bug-out bag. You hope you never have to use these things, but it's smart to have them on hand. And when we see these rhythms in global seismicity, that's your clue to be like just a little bit more alert. Not afraid or fearful or stressed, just be aware. Conscious and aware, that's the best policy. That is what I believe. But we zoom in here, you can actually see it already. Look at this low density zone right there. That is our earthquake in Japan in 2011. This extremely low density solar wind right here at that 2011 earthquake where it bottomed out to 0.1 for, let's start right there. I mean, this is also very low, but let's go straight to where it totally bottomed out, okay? So we're being, and that's at 2130 on the 5th, okay? Now all the way to the 8th. So that is about 3.5 days. Was that 2130 that I said? Sorry, 3 days. 3 days where we had super low solar wind velocity. And then we did start to have it go up again, though we had these other low density zones there, right? And then the earthquake popped off. And the earthquake for Japan 2011, I'm sure I could, 2011 Japan earthquake USGS. I'm sure they have a event page for it that will give us, yeah, the Great Tohoku earthquake that caused the Fukushima problem. The meltdown, that was at 5:46 universal time, okay? So we can go back to our real-time solar wind, and let's get exactly 5:46 UTC on the 11th. And so that's gonna be, and here we have 5:30, right in this low density zone right there. So there's a lot to this. There's a lot to this. It's not superstition. This is science. Mainstream science may take some time to catch up to it, but that's how science is actually. You get people that make these connections, realizations, usually decades before it actually enters into the public consciousness and awareness and becomes accepted by the mainstream. So I just think there's absolutely something to this, and history will prove me right or wrong, and others. I'm not the only person to ever talk about this. There's a lot of people doing amazing research. I'm just more of a public face for this, you could say, with this channel. If we look at our magnetic field data from the peninsula, the Kamchatka Peninsula, we don't see any magnetic anomalies from this earthquake, whereas we did from that 7.3 in Alaska, which was very striking. Because we have our data here. This is our Z component for the magnetic field, and then we have our H component right there, our horizontal and our vertical component. And we don't see any significant deviations right around, this is all universal time. So the earthquakes, you could cluster them, let's say at 7 a.m. universal. The magnitude 7.4 for Russia was actually 6:49 universal time. So it would be right just 1/3 of the way in here. And we do see some of the data, the line not being as solid for whatever reason, but we don't see any anomalous spike like we saw with Alaska. So it doesn't look like there was any significant magnetic anomaly generated from the 7.4. But there are some weird things there. Like, for example, we're missing a KP index for that time block. I don't know why. Maybe it's because they pulled out some of this data. Maybe there were some spikes and they really like pulled out some of that data and filtered it. I don't know. But either way, the traces are looking normal. Whereas on the Magnetic Field Observatory for Alaska for the 16th, it was definitely very, very bizarre. We can look at our Schumann resonances because we have a station that's located in Tomsk, Russia. So nearby to the west of Kamchatka. And we do see some interesting activity in the Schumann resonances right around the time of that rupture. This is all universal time plus 7, which is local time for Tomsk. So we're going to have to take our universal time for this earthquakes, which is again roughly 7 a.m. for those 4 high magnitude earthquakes, and then add 7 hours to that. So it'd be right around 1400. But really for the magnitude 7.4, it would be 1349 universal time. So we do have this energy there, which is interesting. And it's not necessarily in that pre-earthquake signal zone though, which is usually 20 to 30 hertz. So it'd actually be this zone right there. This is 0 hertz up top. This is 40 hertz down below. Here's our power legend. Blue is low power. If we go up to these hot colors, that's high power. And what we're measuring here is the vertical electric field. So you have the ground surface, you have the ionosphere, there's an electric current that runs in between them, and you can measure the vibrations on that current in this frequency range. And often we see fluctuations in these vibrations and in the Schumann resonances, which we see here, these stable standing waves of light energy that are always propagating across the Earth globally. Our brains make them, our hearts connect to them, a whole bunch of interesting things, which I discuss on the channel about them. Those undergo deviations sometimes with powerful earthquakes. So really demonstrating our connection that we have to the Earth, like really strongly physically, and there's a lot of spiritual connections with these. They could be a collective consciousness, some interesting stuff. They're an energy and information field that's just been resonating on this planet for millions, if not billions of years. So we often see changes in those before and during, and maybe even like slightly after powerful earthquakes. But this earthquake specifically, again, was off the coast. It was under the ocean. And so a lot of these electromagnetic emissions will get absorbed by ocean water because it has a very high conductivity, about 4 Siemens per meter. So when you have something that's conductive, it absorbs electromagnetic energy. Whereas if that earthquake had ruptured on land, we probably would have seen something really clearly pop up in the Schumann resonances. But we do get this activity there, and it looks kind of scattered, and it looks like it could be related to that earthquake. It's hard to say. We do get this, a little anomaly right there in mode 4 with that pre-earthquake signal zone, but there's nothing super obvious like we've seen before, like these streams of energy that kind of have this curved motion to them. We saw that back in 2023, February 6th, with the magnitude 7.8 and 7.5 in Turkey. That struck the land, right? No ocean to absorb them. This is pretty close to the epicenter for Kamchatka, but we don't see anything very obviously pre-earthquake signal, but this activity there could be related to it. But what this is kind of showing just in general, and some of this talk about the ionosphere and these glow-tech anomalies, right? These guys here, is just showing that there is a very strong connection between the crust of the Earth and what's happening, these energy flows underneath the surface and the atmosphere, and that connects out to space. So we have all the different layers of the Earth energy onion, as I call it, connected together. Some of the layers, you know, they have their own energy flows within them, of course, but there are also connections between them, going from all the way to the core to the outer edge of the magnetic field into the solar wind. They're all connected together. Question is, what's the significance of the energy flow and the connection, and what's the variability of that? Sometimes for example, the magnetic field of the Earth undergoes these fluctuations. Let's actually pull that data up. We can look at that specifically by going to the Earth Analytics page on earthevolution.com/energy-analytics. This is my website. I've compiled a variety of data graphics and feeds for you to use in your own research if you want, or just keep track of things. The link is in the video description. Here we see this 7.4 right there. So we're seeing that we're having this increase in earthquake activity now. I think that's likely to continue. But here we have our radiation belt model. And I think I'll need to, oh, no, we're going, great. So here we have our radiation belt model. Here's the magnetic field, okay? Generated in the core, but there's also magnetic fields that contribute to Earth's magnetic field depending on where you are. So if you're near, let's say you're in a spaceship and you're hovering around the ionosphere, all right? You have some special spaceship that can just float around and you're up in the ionosphere. A lot of the magnetic field strength, 1,000 kilometers up, is actually going to be determined by these electric currents that are flowing in the ionosphere. Of course, this magnetic field generated within the core is going to matter, but a lot of the magnetic field strength and the variability of that is actually generated by these electric currents in that zone. You go further out to the magnetopause, where the magnetic field interacts with the solar wind, same deal. There are electric currents that are generated by the interaction of the magnetic field and the solar wind that generate their own magnetic fields that add or subtract to the stable magnetic field of the Earth, because it just kind of has this field that decays outwards. So it's not just the magnetic field of the Earth that's generated in the core that matters. It's all these other secondary and third and fourth order magnetic fields that influence the magnetic field at any single given location on Earth. For example, the magnetic field fluctuations generated in the ionosphere, again, 1,000 kilometers up, 300 kilometers up, they influence the magnetic field down at the surface. They're powerful enough, right? If they're strong enough to cause magnetic swings of 400, 1,000, 1,500 nanotesla at the surface, 300 kilometers down, think of how strong they are up there at 300 kilometers. They decay just the same with the inverse square law. You go double the distance, you decrease the strength by 4. So that's pretty significant. It's like an exponential decay, or if you get closer, an exponential increase. So these magnetic field fluctuations in the ionosphere are very, very strong. And so we have our magnetic field connecting all the way out. These changes that occur do connect all different parts of the Earth together. And so you can have the solar wind interact at the magnetopause that can then influence, for example, ion precipitation from the radiation belts, which are closer in. These are about 1 to 10 Earth radii away from the planet, starting outside the ionosphere, though part of the radiation belts near Brazil, for example, will actually cut into the ionosphere. When the International Space Station travels through the South Atlantic Anomaly, where the radiation belts dip down to like 400 kilometers above the surface, they receive more radiation load as a result. It's a problem for satellites and the International Space Station, the astronauts there. But we see our radiation belts have been getting pretty supercharged. Look at our date there. We're coming up on what right now. Look at the flux, very, very high. And right there is where we are. We just dropped now to the 14th again, the cycles. So our radiation belts are charged up too. So as it relates to what's coming up around the 24th and 25th of July, we have the new moon, which is going to increase the tidal forces on our planet, not just ocean tides. People think about ocean tides, how they get stronger or weaker depending on whether it's full moon, new moon, quarter moon, right? It's also earth tides. There's an actual displacement of the solid earth that occurs due to the forces, the gravitational forces of the sun and the moon. It's crazy. That changes global seismic patterns by about 0.5 to 1%. And in general, we see the highest magnitude earthquakes cluster around new moons and full moons. That's not always the case. We're on right now a waning crescent moon phase, because the new moon's coming up around the 24th of July, 25th for Japan time. Right now it's the 20th. So we're coming off of that third quarter into the waning crescent. So it's not the new moon yet. We had the 7.4 or cumulative 7.6. That's pretty big. It's not always that we get them to cluster around new moons and full moons, but in general, that's what we see. The last biggest earthquake we had, which was the 7.8 and 7.5 in Turkey, that was exactly with the full moon. So we get, for example, changes like that. We also have these space weather inputs, and that is something that more and more people are waking up to, realizing has an effect, and we really need more people crunching the numbers so we can really tease out the significance of that. We also simply just need more time. Our data from the space age only goes back to, let's say, at a maximum, Sputnik, basically. I mean, we have sunspot numbers going further back, and we have some other ways of observing sun that go further back than Sputnik. But as it relates to like the radiation belts, we never observed the radiation belts in their normal environment before we started altering them with like power line harmonic resonance and all these other man-made electromagnetic radiations which stimulates greater precipitation. We don't know what they looked like back in 1800. We simply don't. They could be dramatically different now than they were then because there's greater ion precipitation in general across the globe right now as a result of power line harmonic resonance. This is 50 and 60 hertz noise, which causes ion precipitation, creates these magnetic ducts in the ionosphere going out to space. Also, all the cellular networks, 5G, the special frequencies used by first responders, military, all that stuff, right? All this affects our energetic environment. And so it's the observer effect, right? You observe something and that actually changes the outcome. But we have that basically happening all the time. All the next red towers now that are pumping out gigahertz frequencies to monitor the weather and everything, that's affecting how much energy is being absorbed by water in the atmosphere, therefore changing to some degree, to some significance. What the significance level is, we don't know, but it's changing undoubtedly to some degree the latent energy and heat of our atmosphere. So all this stuff is super, super connected. It's kind of hard to put it all in your head at the same time. That's why I do my best to present on this channel. But it's all connected together. So when you have these ions precipitate down, you have this greater geophysical flux, stronger electric currents in the ionosphere. We know the ionosphere is connected to the crust. They're like capacitor plates effectively. They're conductive here, conductive there, resistive in between with the atmosphere. Generates these strong TICs, or GICs rather, geomagnetically induced currents. If that passes over a fault that's at a critical stress, perhaps that causes it to rupture and maybe we get this plasma emission from it. This is all, and kind of my framework hypothesis that I'm building based off of the amazing work and research of many people and my own thought experimentation. But it's a very elegant hypothesis, I think. The plasma basically understanding of this really makes things easy to understand and you don't have to get complicated with it to just visualize the way it's working. So we have these effects. We have this energy spike coming up on the 24th, 25th or so, but we're already seeing the energy spike on our planet because of this increase in global seismicity, most recently with this magnitude 7.4, 3 magnitude 6.6, a magnitude 6 and magnitude 5s and other aftershocks here today in Kamchatka. So yes, wild stuff right now at this moment in time. One last stat I'm going to give you before we move on to the question and answer. So prep your questions. If you do a super thanks, I'll answer those first. That might be all I get to depending on time. I see a lot of super thanks in the chat. But that 7.6 cumulative magnitude is equivalent to 253 Hiroshima bombs, 189 Nagasaki bombs, or 3,800,000 sticks of TNT. But as it relates to the largest ever nuclear test, the Tsar bomb, it's only equivalent to 0.06 Tsar bombs. So not just 6% of a Tsar bomb. Now, if we bump this up to 8, let's see what happens. If we go to 8, now we are at a quarter of a Tsar bomb, and I bet if we go to like 8.3, we're probably now at a Tsar bomb. Nope, not 8.3, 8.5, let's say. If we have an 8.5 earthquake, now we have the total energy release is equivalent to 1.5 Tsar bombs. So once we get to, let's type in that 9.1 for Japan that occurred in 2011, right? Now you have 12 Tsar bombs. So that was a very powerful bomb. Think about all the nukes that we detonated over the decades, 40s, 50s, 60s, 70s, 80s, 90s. You don't think that affected the Earth? You don't think we're still dealing with these energy changes on the planet? Like, oh, you dropped a bomb, or you dropped like thousands of bombs, and oh, the effects are done in like 2 days? No. Probably a lot of the things are unfolding on the planet right now in terms of like climate change and whatever, all these odd things are probably tail effects of the millions of nuclear bombs that we dropped on this planet. And no one's talking about that. I haven't heard anyone talk about that except me, basically. There have been research papers done exploring the geophysical effects of nuclear testing in the immediate aftermath and how you can have like literally aurora on the other side of the planet after a nuclear bomb because of particle decay and all these crazy things. But in terms of people bringing awareness to, oh yeah, all those nukes that we dropped, you know, that didn't hurt the planet at all back in the 60s and 70s and 80s and 90s. Like, you know, they've tried to pull the cloth over the eyes. Don't let them. Like, that is one of the biggest, that's probably the biggest crime ever committed to this planet. That's it. All those nuclear testing, and of course, you know, these tragedies that occurred right there, let's not forget that. Horrible tragedies. Yeah, really not good stuff. I feel like I have to point that out every time it kind of gets brought up, or at least have the opportunity, because it's honestly a responsibility for us to remember that, be aware of it, cognizant of it, and fight against that, because that is really tragic stuff. So let's go into our question and answer. And let's start with what we got. So just a mahalo from Ginger. Thank you so much for the super thanks. And we have another question here, or this is just a thank you. Thank you for your dedication and hard work. Love how you can always count on you for our daily space weather. Truly grateful. Well, thank you so much, Jamie. Really appreciate that. Sherry with the super thanks. Longtime supporter of the channel. Thank you so much, Sherry. And we have a question here from Rochelle, which is asking, how would a magnitude 9 in Japan, for example, affect the rest of the Ring of Fire? Well, that's a good question. Well, a couple things I'll say there, and this is not going to be a comprehensive answer, because no question is ever no answer is ever comprehensive. Every thought is an abstraction. Keep these principles in mind. But you need a bigger fault to rupture to have a higher magnitude earthquake. So with a magnitude 9, let's say here, you're going to actually have a lot of that fault rupture, a significant length of that fault or rupture. Or if we go over to our magnitude 9.5 rupture in 1960, right, a significant portion of this subduction zone ruptured and moved as a result. And that scales such in a way that if you were to have a hypothetical magnitude 10, right, which we've never observed, and there's no geologic evidence of, as far as I know, but a hypothetical magnitude 10 would require all of the faults. Let me go over here. Hypothetical magnitude 10 is going to require all the faults of the Ring of Fire going like this to rupture at the same time. That's simply probably not possible. That doesn't really make sense. I don't resonate with that idea. Some people are talking about that. They're calling it some like Culebra event or something. You know, they're making up these ideas of some megalithic or mega apocalyptic disaster. You gotta filter the signal from the noise, in my opinion. Now, I don't know. I mean, maybe the Earth is possible and it can do something like that. But in general, the higher magnitude, an earthquake, the bigger the fault that's going to rupture. So with a magnitude 9, you're going to get quite a significant fault rupture there. It could trigger other earthquakes nearby, and it's definitely going to have a lot of aftershocks. And so if you have a magnitude 9, expect probably a magnitude 8 aftershock, or at least multiple magnitude 7 aftershocks. And they may even be a little distributed out across the fault, because again, the entire fault, like a broad portion, is rupturing. So it could be beyond just a zone. We could also get ruptures maybe here and here. Like, that's something that you could expect for the rest of the Ring of Fire. But that is a big release of energy. You get a magnitude 9 to rupture, that thing has released a lot of energy. So it's after that occurs, it's cooling things off, you could say. We have a question here from Divas, which is saying, hey, we live on the New Madrid fault line, and the river's having big changes. Just wondering what you think. Thanks for all your hard work. Yeah, I have heard about these like cracks in the Mississippi and some of these things and changes to the river. The Mississippi has been bottlenecked in many ways. Like, this river used to flow a lot more in a lot different channels than it does now. That's one of the unfortunate things as it relates to modern human civilization, is that we've changed a lot of these natural tributaries for significant rivers. Like, I mean, look at all the Oxbow lakes here, these bends, right? At some point, you know, these rivers flow through different areas as they carve the landscape. And you see the larger zone where the Mississippi has been, okay? So it's kind of locked up. Now, as it relates to these cracks in the bottom of the Mississippi, I don't know. There's a lot of fake news stories running around. People will take old clips or something and say it's new. For example, I'm not sure this is the case 100%, but there's a story right now that all the animals are leaving Yellowstone. Well, one of the clips that was used was actually like an old clip from a fire, and the animals were fleeing the fire. Another one looked like it was generated by AI. So people make up these stories. I don't know, you know, it's impossible for me to look into everything. I don't know about this cracks in the bottom of the Mississippi, but New Madrid is a significant fault zone that definitely could rupture. We can look at our seismic hazard map, in fact. If you go here and we can zoom in on the United States, and we see the New Madrid fault zone right there, and that's a significant hazard zone. So definitely something to be aware of, but the recurrence interval on a big earthquake there is very low. So it's not necessarily top of mind for me. When it happens, this is kind of my philosophy, when it happens, just be prepared. That's the best thing you do. Don't lose sleep over it, just be prepared. Don't change your life around it. Like, go enjoy life, live every day to the fullest, but be prepared. So if something happens, you're ready to go as best you can. That's my philosophy. So thank you, Divas, for the super thanks. And this is a question from Goat. Will the TEC help split Africa? And kind of an odd question, but I know what you're saying. So we can go here, and here's our total electron content map. Again, we're seeing these weird anomalies, and they're popping off over Africa. We have the East African Rift Zone going right through there. There's been a lot of activity there. Over the past year, specifically around like Ethiopia and near the capital of Addis Ababa. So that has kind of cooled off in the past 6 months, but there were some weird things happening there. That is driven in part by a super plume coming up from the mantle, splitting apart Africa in this zone. So will these anomalies in the atmosphere trigger the rift in Africa to all of a sudden happen? No. But in general, you're going to see, you know, there is that connection between all these different layers. You are going to probably see more of these sort of anomalies just over geologic time as that slowly continues to rift. And actually the New Madrid zone, that used to be a rift that then failed and then got covered over, and now all those old faults, every now and then they slip, triggering like a magnitude 7 or a magnitude 8. That's why that's a hazard zone, because there's an old extinct rift valley from the Precambrian underneath, in the middle of the continent, underneath all the sediments. And so this rift zone could perhaps fail. And then, you know, 600 million years from now, it could be in a similar situation. But it looks like that's going to continue because there's tons of volcanic activity all through this zone and into the Red Sea and more. So, but is Africa going to rift apart tomorrow? No, it's not going to happen like that. It'll take thousands, tens of thousands, hundreds of thousands, millions of years for that to occur. And a question from Captain Bluetooth, thank you for all you do. I recently ran across a Raspberry Shake. This is like a collective earthquake monitoring network that you can get like a little Raspberry computer, and they're called Raspberry Shakes, and you can put that out and it'll measure this data. And wondering if you have any experience with these units. Seems like a cool way for us to contribute to the science. I don't with Raspberry Shake. I do have my own seismograph. I don't have it set up right now because I'm in an apartment. So the moment I can get my own land, plot of land, and I can put that bad boy in the ground and get that live data feed on my website, I'm going to do that. So I bought the seismograph, I have that equipment, it's really good 3-axis component. Raspberry Shake is a good way for anyone to get into that. Yeah, so good suggestion to anyone that's watching, that's interested. And Nix is asking, do you think the warming of our planet could be a cause of future earthquakes like the freeze-thaw of winter-summer causing cracks in pavement? Or just in general freeze-thaw erosion, which is a natural geologic process? Could that have a similar effect on Earth's crust if it's under more pressure? Thanks for being you. You're my favorite. And thank you, Nix, for the very generous super thanks. $100. It's incredible. Thank you so much. That's a very interesting question. We do see the planet warming up overall, at least in the atmosphere. And we also know that there's a radiation imbalance right now with the Earth. Our long wave, infrared, radiation, so that thermal heat, is not radiating out at the same level as inputs. So we are slowly accumulating heat on this planet. That could be contributing to all this. Now, the heat storing capacity of the air is quite low. The heat storage capacity of the oceans, of water, is much higher. I think it's like 4 times higher, something like that. The heat storage capacity of the Earth is a lot higher. So that's going to be the last thing. You know, it's going to be the slowest to heat up. But if we have this radiation imbalance, probably is heating up. It'd be good to see if there's like direct ground temperature measurements in like distributed areas in nature across like 100 years. Maybe we have that data, maybe not, I don't know. To see if we are seeing like, let's say 20 feet down, that surface temperature going up, that crustal temperature. That'd be interesting. But based off of everything that we know, I would think that we probably are having very slow temperature increase of the Earth itself, and heat is expansion. So you are going to, with expansion, drive more faulting activity and things of this nature. So it's very possible. It's very possible. I think it's a good question and definitely something to research more into if you're interested in that. And we have a question from Matthew, which is saying, or maybe he's just a fan, pretty awesome information here. I'm a lineman, and yes, this stuff affects power lines. Incredible. Yeah, geomagnetic storms affect electrical grids and more. So yeah, everything's connected together. The question in my mind is not the connection, it's the significance level of that. So yeah, thank you so much for your super thanks. We'll take a couple more questions from the audience. So just type @Stefan Burns and I'll ask those questions. I'll answer those questions as best as possible. Please stay on topic. And we have a question here from Seeds of Light asking, is there an orographic effect for the electromagnetism around mountains? I'm not sure what you mean by orographic effect, but what we do see with earthquakes is an increase in the accumulation of positive charge in the mountain areas before and during and after an earthquake. So maybe that answers your question, but I'm not sure what you mean by orographic effect. Maybe you're talking about like orgone. I'm not exactly sure. We have from Calyx saying that Kilauea is erupting. And actually, I forgot to show you this. Let me show you this. We have our seismic waves here propagating from that 7.4 in Kamchatka. Of course, think about the fact that we also had the 6.6, the 6.6, the 6.6, and the 6. So we have multiple waves of seismic, you know, these waves and ground motion from this most recent earthquake swarm in Russia. But look at how this energy, the surface waves, are propagating across the seismic network going from Alaska through the United States, Canada, into the Caribbean. So these are powerful releases of seismic energy, and let us look to see if Kilauea is erupting and what that eruption looks like, because we always like to track that on the channel. USGS has a live stream for Kilauea. Let's see what is happening. And oh yeah, we got a nice eruption going on. Not the biggest, but it's starting up, folks. So let's check this out. Boom shakalaka. There is our favorite volcano in Hawaii, now undergoing its 29th episode, and looks like this is just starting up because what we typically see is this will now reach like 1,000 feet or higher with its spout. So this is just starting up. Thank you, Calyx, for pointing that out. One from Zoya here. Is a big rupture expected in Los Angeles? It's been quiet in our area compared to the rest of the Ring of Fire. Good point. Yeah, California has been very quiet seismically for a while now. Now, we did have the magnitude 7 that was near Petrolia. That was the very far northern part of California near the border of Oregon at the Triple Junction. And we did have a 5.2 in San Diego recently. Then there was the Ridgecrest quake. I believe it was 2019. That was like a 7.3 maybe, something like that. That was Central Valley. But in general, the rest of the Ring of Fire is always popping off with 6s and 7s. Like we just saw 7.3 Alaska, this cumulative 7.6 in Kamchatka, the earthquake swarm in Japan. what the heck is California doing? California has a strike slip fault, it's not subduction, so the overall magnitude is not likely to ever get past an 8 or so. And there are parts of the San Andreas fault that are always continuously releasing seismic energy. So these are all just a whole bunch of low-grade magnitude earthquakes that we really don't pick up. So that's interesting. But there does seem to be like a longer reoccurrence interval in California where it really builds that stress up and then it releases. And if you look back through the record, you go to the 19th century, there were a lot of earthquakes that occurred in California in the early 19th century because the mission network across California recorded that. A lot of missions got destroyed by those earthquakes. Then you had the Fort Tejon earthquake. That was like mid-19th century. And then, of course, you had the San Francisco earthquake, early 20th century. So we are kind of overdue for like a big earthquake, especially the Hayward Fault in the Bay Area. As it relates to Los Angeles, that's probably even more overdue because the last big earthquake in SoCal was the Fort Tejon earthquake. That was like 1852 maybe, 1848, something like that. So I've kind of given up on trying to predict earthquakes in California. I just seem to always leave California right before they happen. So if I fly out somewhere, maybe that's your clue. And Natalie is saying how much land, you can put a seismograph on mine. She's in central Illinois. Yeah, I'll have my own land soon. Eventually I'm going to build out a USA network. So when that time comes, I make the announcement, then please reach out to me then. So yeah, thank you all so much for watching, everyone, for your questions. I hope I provided some clarity on the situation, what's happening with the Earth. I'm looking at the dates of July 24th and 25th very carefully, but in general, we are in this wave right now. Whether this seismic wave is going to continue to propagate around the globe and hit other places, that's unknown. I think it's likely we get more high magnitude earthquakes over the next couple weeks. We have a lot of sunspots on the sun. We have that fourth coronal hole high-speed stream about to hit us right around, again, the 24th, 25th, maybe the 23rd, it'll go geoeffective. But we are right now in a very low density solar wind regime, which is what seems to pull these high magnitude earthquakes out of the Earth. So if you'd like to stay up to date, then please subscribe to the channel. I've been your host, Stefan Burns. Smash that like button to help this channel grow. I put a lot of work into this channel. We've built an amazing community here of open-minded and pure-hearted individuals, hopefully as best as possible. So if you like the sound of that, then please subscribe. We also talk about some of the more spiritual dimensions and domains quite frequently on this channel because everything's connected. We seem to be undergoing a big Earth shift at this moment in time that's driving some of these changes that are manifesting in the more 3D material realm, like with for example, like an earthquake. So if you'd like to stay up to date on all that and more, then just join the channel, and happy to see you here. And thank you all so much for watching the live stream. Wishing all of you well. Please take care of yourselves. Enjoy your Sunday or maybe even Monday, depending on where you are. But wishing you all the best, and I'll see you all very soon. Thanks so much.